This video is an attempt to get you over some of the initial hurdles for the latest computer assignment, which is this one for the simple mover and the simple mover managers. Now, the simplest mover and corresponding mover managers that were discussed in class are the simplest version of these, but in order to have slightly more functional ones, we need to extend them a bit, and that's what this is about. In terms of what you'll need to do this, pretty much everything is just a bit of a tweak on what was done with the simplest mover and just applying things that we have been talking about all quarter. So what I'm going to do is just show you how to get started with this. And it's the standard kind of thing, with the one exception is that our simple mover is going to also extend, in addition to extending SimEntity base, is going to also implement an interface. So let's see how that is. So the first thing when implementing a component in SimKit is to extend SimEntity base, and in this case we're going to also implement the mover interface. So let's see what that looks like. So let's create our new class, call it simple mover, and as is typical, we will extend SimEntity base fix that, but we were also going to implement the mover interface. Now, there are actually two mover interfaces in SimKit, and it's important that you implement the right one. That is the one that says simkit.smd.mover. Okay, if you accidentally import this smdx one, then just delete the X and you should be fine. Now, at this point, we get a red squiggly, and what does it say? The simple mover is not abstract and does not override abstract method get max speed. So whenever we get that does not override or is not abstract, then we can simply implement all the abstract methods. That makes the red squiggly go away. And we see that there are 2, 4, 5 methods that are specified by the mover interface. Those are get current location, that's this implicit state we'll talk about in a little bit. Get velocity, which is just the getter for the velocity. And notice it's a 0.2D. Okay, the do start move and do stop events are again specified by the interface. Notice that they have an argument which is a mover. And since our simple mover does implement mover, that's going to satisfy that argument. And finally, get max speed. So those are the things that a mover interface must provide, and typically they're going to be a bunch more. So the next step in implementing a component from an event graph is to write the parameters. So let's take a look at what we have. 2 parameters, just as we had in the simplest mover. We have a 0.2D, that's our initial location, and we have a double, which is our maximum speed. So those are private 0.2D, initial location, and we have a private double, which is our max speed. Just as with the simplest mover, our simple mover is only going to run at this one maximum speed. If you think about modeling with a little bit more detail, you might consider the fact that there might be a number of different speeds that the mover could be operating at. So there might be yes, a maximum speed, but there might be a cruising speed. There might be just sort of a, if it's patrolling, there might be a patrol speed. There might be a number of different speeds that could operate. Again, all of that is just more complexity that we're not going to deal with here, but understand that it could be dealt with at some point. So we want to encapsulate these fields. And one of the things to notice here is that you see the get max speed is already declared. That was part of the interface. We got to be careful. The field's visibility should be private. Let's put these as the last method. And we see, okay, we have the setter, and then the setter and the getter for the point 2D. And then one thing that we'll have to really do by hand here is return the max speed. And since max speed is a primitive, that is a double, we don't have to worry about copies. But the initial location, we do. So we should return a clone, and because of the way that point 2D is written, we need to clone it but then cast it. Again, it's not a big deal, but it's just the way it's just something. Oops. Okay, so this is all to protect encapsulation. And if you don't do this, then it's actually very easy to run into problems, especially with this, with points kind of running around. It's all too easy to get into a situation where some other object has a reference to your point 2Ds, and if they change the coordinates on that, then all of a sudden you've jumped to another place. So until such time as they actually invent actual transporters, then we're not allowed to do these things. In simulation, it's called a magic move, where just an entity all of a sudden gets transported from one place to another. Okay, so, and as usual, we want to have both a zero argument constructor, and we'll be using that for the state variables, as well as a master constructor. And the master constructor, in this case, will have both of our parameters. And we do want to call this, because we're going to be using Simple Mover to instantiate our state points. But again, as this should come almost automatically. Where we set all of the parameters that have been passed in. And so at this point, again, I encourage testing right away. So let's, we can keep putting put it in a separate, well, nah. We'll just throw everything into the mover package. Okay, so I'm going to call it run movers, because I'm going to keep putting stuff in there. Okay, so why do this? We want to confirm before moving on that all of our parameters have gotten in. Initial. And where should we put this? Let's, again, we're just putting it somewhere for testing purposes. And one thing about NetBeans is it actually, okay, what I'm doing here is, since I have two constructors, if I put my cursor in between the parentheses and I'm hitting, not perfect, but in this case, because the names have more or less matched, um, it actually guesses correctly. And I just do a print line because I want to make sure that my values have actually gotten in. So, okay, so that's a check. All right. If somehow, okay, what could go wrong? Okay, that was a goof here. So, what could go wrong? Well, let's say that I forgot to put this in. Now, all of a sudden, I'm getting all these null pointer exceptions. And now here's the thing: is that you really should become good at reading what all this red, the sea of red and blue, is about. That has a lot of information. It's not always perfect, but there's information in here, and so to keep you from flailing around and making changes that aren't helping fix the errors, it's important to read these errors. So exception, runtime exception, and it says null pointer exception, cannot invoke point2d clone because this initial location is null. Okay, so that's a lot of information there. And then they have all this other stuff is. This is the so-called call stack. This is the sequence of calls that this is done. Somewhere in there is a link to your class. So what you want to do is you want to kind of comb through all these different links. These are all things in SimKit. Print stream is actually in Java. Okay, run movers, that was something you wrote. And then what was the problem when we tried to do a print line with that? Right, but right underneath it is a simple mover, and that was returning the initial location dot clone. And our error said this was null. So what was the problem? Okay, I say, well, wait a minute, it's not null. I instantiated it here. But I didn't pass it through here. So the fix is to make it not null. And now when we run it, we're back to this. Okay, now if you really take the baby step approach, which I strongly advocate, one of the things that you can do is you can actually commit your commit at this point. So after each step, a commit to just kind of track what we're doing. So we created simple mover, wrote the parameters. Okay, so I'm going to commit that so that if I screw things up, I can revert my modifications and I won't lose what I just done. Okay, so now the next step would be to look at our state variables. Now, when you have object state variables, the preferred way of doing this is to keep reusing the same ones. In other words, these point2ds, I want to have the same instance for last stop location, velocity, and destination, and just call the set location for when I want to change them. So what that means is that they need to be instantiated. And the question is where to instantiate them. And so for state variables like this, the best place to instantiate it is in the zero argument constructor if possible. If possible. Sometimes you need more information which isn't available to the zero argument constructor, and in that case you may have to instantiate it in the master constructor. That was the case in the transfer line. Okay, so let's do that. Where are we here? Oops, that was the simplest mover. Let's define our, oops, that was the run. let's go here and instantiate or define. We have our initial location, our velocity, our destination, and our start move time. Okay, these are all identical with the ones in the simplest mover. Oops, and what are you complaining about? Oh no, sorry, this was last stop location. It helps if we actually read what, yeah, last stop location is what we were calling it. Okay, and then we want to encapsulate these fields. Make sure that they're protected, have no setters, and let's put it as the last method. And then we notice that the getter for velocity is already defined in the in the interface. So now each of these we have to do the same dance as we did before, and this is especially important for the state variables. Again, we're just making sure that we're not returning that we're not returning the thing itself, but a copy. That's what clone does. But then let's see, where was our velocity? Okay, I want to move this down to where it's with the rest of them. And again, we need to return a clone of the velocity. Okay, now unlike the parameters, because the state variables are don't really show up until we actually run the simulation, we need to do a little bit more. But the first thing is we want to make sure that they're actually instantiated. So we're going to do that in the constructor, in the zero argument constructor, and that's to make sure that they're always instantiated. But since we don't know where they are, we're going to initialize them with the not a number coordinates. That's that NAP, or not a point thing that we had. And finally, destination. Oops. Okay, so now, and because we're calling this from our master constructor, these will always be instantiated. Now, just to make sure that they kind of get through, we need to write our reset method. And where do we get that? Where do we get what we put into that? Well, we need to look at the event list, the event graph, I mean. Okay, so here's our run event. That sets our time, start move time to 0. It sets our last stop location to our initial location, sets velocity to 0, and then destination to not a point, which is where it is. But we're gonna set it there anyway for reasons that will hopefully become clear when we start doing multiple replications. Okay, so we're going to set the location of the initial location. And our velocity, we're going to set location to 0. And our destination, we're going to set our location to not a number. And again, if you're worried, you say, well, we already did that. Well, after after a particular replication, when we go to do it again, the destination may be something else, and so we don't want to have that hanging over. So we always want to initialize all of our state variables, either in reset or if they're array state variables in that init thing. There are no array state variables here, so we don't have to worry about that init dance. And again, our start move time was 0. So looking at, we see that our run event actually doesn't schedule anything, so but we do need to fire our property changes. So last stop location. Our velocity. Oops, not indexed. Yeah, NetBeans sometimes is a little bit too helpful there. And finally, okay, now at this point, we want to test again. Okay, we already have our simple mover instantiated to be testing these, and this is why we run in verbose mode with that simple property dumper business. Okay, so we have our simple property dumper. We add it as a property change listener to our our simple mover. We set verbose for our event list, and now we can actually run it. Believe it or not, all we're going to get is the run event, but that's what we're looking for. We're looking to make sure that the initial location, the initial state variables, are all correct. So here's run. Our last stop location is the same as our initial location. Our velocity, why are we getting two velocities? Because I wrote two of them. This should have been destination. This is why we kind of do this, because this you want to pick up anything. Destination, what happened? Oh, I want to call the getter. So you see, fat fingering happens all the time. So this is why we take things step at a time. So here's last stop location, check. Velocity, check. Destination, check. Start move time, check. Okay, so again, just to kind of take a look at our event graph here, let's I'm going to do the move to for you, and I'll leave all the rest of them for your enjoyment. Okay, move to takes a signature as a point 2D, and you got to keep in mind what kind of how to translate this. This says we set the destination equal to the argument. We don't want to literally do that. We want to set the location of the destination to the argument. Okay, so we need to be careful about that. So let's see what that looks like. Now, you can either call it the same as destination, or you can call it something else. So this, I often like to call it by the same name as what I'm going to use it for, but you just have to be a little careful now. I'm going to have to use a this when I to avoid referring to this one. If you don't like that, you can call this a different name, and that would work fine. But we do the old value, new value business. First, we get the old one. Now, for this, and it's always safer to say this, but we can set the destination again now to the argument. You just need to watch the colors. So the green means it's an instance variable. The black means that it's the argument. See, so if I click on that, that's there. If I click on this, then I do not get the others highlighted. So now I've just, did I spell it right? Okay, so now I, again, fire a property change. And I give the old value, and the new value is the new one. And then what it also has to do is now I schedule a start move passing this. Okay, so what does that look like? See, unlike the other one, in the simplest mover, we didn't pass anything, but this is we literally passed this. That is a reference to ourselves. Okay, so now how to test this? Well, ultimately, this move to is going to be heard from our mover manager, but we haven't implemented the mover manager yet. And again, that's something I'm going to be leaving to you. So here's how we can kind of at least mimic that, is we can literally, between reset and start simulation, and again, this is not something that you, this is not something that we will ordinarily do. This is only for testing. But we can actually call wait delay move to, and just to make sure it's happening, let's say make it happen at 1.5, and then we want to give it a destination. So let's call it, it needs to be a point 2D. Oh, let's make it minus 15 and 25. And you may have noticed that I always like to put the decimal points in. In this case, it's not totally necessary because Java will promote it, but that just indicates, the decimal point indicates that I know that it's a double. I wasn't thinking it might be an integer. Okay, now when we do this, I'm going to get a sea of red, okay? But again, when you get all that red, don't panic. And all right, so let's run it, and there's all our red. But here's what I'm looking for. First of all, just verify we're still getting our run is still initializing things. Okay, and this is one of the things I was looking for. So look, see, it's scheduled move to at time 1.5. Now at time 1.5, it said move to. Its argument was the place we were sending it to. Okay, so that means that move to seems to be working. Okay, we have a state transition. It's scheduling the right thing, and then this is the red that we the sea of red that we have. Now, again, when you see this, don't panic. All right, so let's read this because it has the information that you want. You might have to pour through it a little bit. So okay, so the event through an exception while processing, the event being processed is start move. Okay, so basically that's just an echo of this. If we weren't running in verbose mode, then we would get the information about what was going on. Okay, the listener is our simple mover. It says listener because we get the same error whether we're executing the event or hearing the event. Okay. Now, some of these invocation target exception, you don't have to worry about that. But what you're looking for is the caused by. See, there's the caused by. And what does it say? Java Lang unsupported operation exception not supported yet. And then when you find that caused by, that's where the link to where the problem was. Okay, and so that's because in the skeleton of the do start move that NetBeans generated, just to make sure that you actually put something there, it throws an unsupported operation exception. So if we want to run it without all that, then we can simply comment that out, and then now then notice that the start move event actually occurs, but it doesn't do anything because there's nothing to do there. Okay, the final thing I'm going to do for you is notice that the argument, when there's an argument and it's an object, it invokes the toString of that object. And the toString here does not give the kind of information that we really want. In other words, what I want to know is where the heck that simple mover actually is, or what does it think it is. So that's where that implicit state of get current location comes in. So the way to fix that is actually kind of twofold. One is to write the current location one, and where do we get that? We get that from actually the definition, the implicit state. That's the last stop location plus sim time minus our start move time times velocity. So let's okay, so let's define a local variable. Just this is all just for convenience here. We don't have to do all this, but I'll define an elapsed time to be the difference between sim time and the start move time. And my mouse keeps doing this. Okay, so cannot find symbol schedule. We'll fix the imports. That should bring schedule in. And it doesn't like the way I spelled get sim time. Okay, so now what I'm going to do is just because these are vectors here, and unfortunately there are no methods directly in point 2D that I can apply here directly. What I need to do is do it for the X and the Y separately. So I get the start move, not the start move time, the last stop location time, or not time, get X plus the elapsed time times the velocity's X coordinate. Okay, do you see how that is? That is what the X coordinate of this equation is. and then I want to do the same thing for y. And what you call these local variables is unimportant. But I get the y plus the elapsed time times the velocity, get y. It's actually easier than you think to accidentally have the x's and the y's mixed up, but then we can now, well, just to take baby steps. Okay, now the important thing here is that notice that this variable current location is not a state variable. It's not an instance variable. Here, syntactically, it's a local variable. All of these are just local variables to make the computation more straightforward. I could have done all this in one line, but I like to do it separately like this because if something goes wrong, then I can run it using the debugger and step through each of these calculations to see what was going on there. Okay, so now at any given time, this is going to return the actual, no kidding, current location of our mover. And so what I want to do is override the toString to give that current location and the velocity. Okay, so, and to that end, I'm going to use the string format business. We've seen that before. Okay, so what's my format going to be? First, I'm going to have the name, because they're going to be a couple different ones. And I'm going to put the location in square brackets. And actually what I want to do here is I'm actually just going to put the coordinates. And what these are going to be are the current location, which I'm going to get from there, and the velocity, which I'm going to okay, so now just to not do this twice, I'm going to define a local variable because I'm going to be doing it twice. So first is the name. Okay, now the next, I got 4 numbers here. The first is going to be the x coordinate of my current location, the y coordinate of my current location, then the x coordinate of my velocity, and the y coordinate of my velocity. Okay, so let's see what that's going to look like here. All right, so now, so we see here that, you see in the move to now, the move to has this. The start move event now has so instead of what we had before, it has the name, which is simple mover .1. Again, there's a setter for that, so we can actually change the name. It has in this case, our current location is actually just the last stop location. That's because the elapsed time is actually 0, or the velocity is 0. So with either a 0 velocity, a 0 elapsed time, or both, that get elapsed time is going to return just where you're sitting there. Okay, but now we're missing something, because our toString here was just giving our not a number stuff there. And we actually want to see the parameters. So, therefore, I'm going to write another one. Oops, not that. I usually call it param string. And that simply returns the superclass toString. So now when I'm printing this, instead of printing just the simple mover, I print the param string. I run that, and now see, now I get my stuff here, and then you notice that there's if I don't do anything, there's it's always nice to kind of see a little space between my parameters and the others. So one easy way to do that is to just put another print line there, just to give a little extra space. Okay. Okay, so what have I done? I have verified a couple things. But the most important is that I've implemented this move to the destination, and I've confirmed that the move to will do the correct state transition on destination, and it will schedule start move, passing this, and then the toString now of the simple mover is giving me information on where it is. Okay, so this should, if you've been struggling a little bit, so here we wrote the state variables, and wrote, that includes the getters. We wrote the run event and tested, and then we wrote the move to, and then finally implemented get current location. Okay, so that should at least get you started if you've been struggling trying to figure out what to do.